Okay.
Okay.
Okay. So first of all, thank you for this invitation. So
Welcome.
I'm going to present Model Clouds that's having the final review right now, this moment. So it's an important day. Yes.
This is why Elisabeth does not.
Yes. So the main keyword here is the clouds, but so I think we all know what's it and why is it important. But the focus of this project is what we call multiple clouds. So the idea is we're a soft team. I think I don't need to present soft team again, so Alessandro just presented us. So we have some projects into making our services available on the cloud. And we noticed that the problem when we do that is that we may get locked into a specific cloud provider if we just developer, for example, for this cloud provider. So we wanted to make sure that when we create this project of having our products on the cloud, we don't get locked into one specific cloud. And that's why we joined the consortium of Model Clouds. That was saying that, okay, we have a way to make sure that your project is, you can go from one cloud to another without lots of problem. And that's what I'm going to present here. So it's a FP7 project. Do we have, okay, I know how long I've been talking. So it started in October 2012 and it's finished in like 1 month ago and having the review now. So I talked about the context, so it's the cloud, but what are going to do with the cloud? So we are trying to provide methods. So you're a developer, want to develop a cloud application, how you do that to make sure you're not close to a cloud provider. We have some decision support systems, so there are thousands of cloud providers, and so why not having some magic box that says, okay, given your requirements, maybe you should try to look at this one or that one. And we have some integrated development environment that's based on Modelio, so it's a modeling tool. And the idea is that having this environment to help developers to design the architecture of the application and connecting it to this method, saying, okay, that's how you should build your application and to connect to these decision support systems. So I don't need to stay a lot of time in this slide. So clouds are very good. Clouds are better than having millions of companies in the whole world, each one with 10, 100, 1,000 servers. So maybe why not having some big companies with tens of thousands of servers and get what all we have from this economy of scale, and it's better for the companies that buy it, it's better for the companies that provide these services, and it's very flexible. But the point is that you can get locked to one specific cloud because you have some specific APIs to create a new VM, you have specific, for each cloud provider you have different provided sizes of VM, so 2 gigabytes of RAM or 10 or 16, things that change from one provider to another. Or we have different services, provider to the other. So how to avoid you being locked into this what one provider is providing to you. And we have this second problem of performance variability. So the point is that maybe for the developer, you have nodes that are on the internet, but in the end of the day, that's software, and then it happens that this performance is going to vary on time. So it's not like you have a physical machine, but have VMs, and then they are competing for the physical machine, and it happens. So these availability problems happen, and that's the main motivation for the multi-clouds. Okay, so what we have here in Model Clouds is tools to help the application once it's deployed to migrate from one cloud to another, to avoid this kind of problems. Okay. So what are the solutions we're providing here? So we have a model-driven engineering approach for how do you build your application to make sure it's cloud provider independent. And we have all this, the idea of multi-clouds to avoid the problems of variability. So it's built in the approach that we are going to have your service provided in different clouds, and it's going to vary during the day, during the time. Just one slide on the approach. So the idea is that we have these different layers of specification when you build your application. So that's the methodology. So you're starting by saying, okay, what's in my application? So what are the services that are in my application? Don't think about the cloud. Don't think about the specific deployment. Think about the application as a set of services that communicate. Then, once you know what's in your application, start thinking about the cloud. Thinking, okay, this service it's a database. This other one is something I'm going to put in a node. This other one is something that I just need a platform to run it. I don't care if it's a node or not. And then once you have that, then you can say, okay, this node is going to be in Amazon. This other one is going to be a database from Microsoft Azure, and so on. So with this methodology, you can make sure that most of your design decisions have been done in the beginning. So you have a nice picture of your application that's independent on the cloud providers. And then once you're advancing in this methodology, you're just adding the details that vary from one provider to the other one. And that's the methodology we implemented in Modelio, in the modeling tool. And that's the methodology we support with these decision support systems and the tools for, once the application is deployed, how to manage deployed application. So then I have these pictures of the design tools. So that is at Creator for Clouds. That's the Modelio extension supporting this methodology. So you can define the application architecture and the deployment configuration. Then we have this other decision support system. So we have this Venues for Clouds that takes your requirements, saying, okay, I don't want my data to be on a different country, or this kind of non-functional requirements, and then it's going to tell you, okay, look at these providers, they may be a good target for your system, or don't look at these other providers because they're not compatible with the requirements. We have this lower level tools, Space for Clouds, that says, okay, I have a map of your application, I know where you want to deploy it, how much resources your services need. So this is the QoS you're going to get if you deploy it. So you can play with these deployment configurations to see which one is the best one, or how much it's going to cost if I change my architecture from A to B. And then we have this tool for deploying the application. So it takes this model and sends it to real servers, and the application is going to run. And then that's more than design time, that's the runtime. So we're not only deploying the application, but we are trying to manage it in a cloud, multi-cloud, in a cloud-independent way. So we have what's called the Energizer for Cloud. That's like an umbrella for other tools that are going to monitor your application. Say, okay, it's independent from the cloud provider, so you get information on how are your services doing. We have Space for Clouds, so that's saying, okay, given the actual performance of your application, that's how you should create more nodes in this provider and send part of your processing to this provider, or send it to the other providers, kind of things. And adapters for cloud, so doing the work of getting a single set of interfaces and adapters for different cloud providers. Okay, so the project's over. So I'm here more to talk about the results than about what we want to do. So support at least these 9 depends on how you count it. So it's 9, but there are lots of other providers supported at deployment time and so on. So this varies from component to another. And you validate it with these 4 case studies. So just to simplify, 2 case studies were about I have an application and I want to make it into a cloud application. And 2 case studies were about, okay, I have a new application and let's design it using your approach. And since we were case study providers, so these are the benefits our developing teams got from the use of model clouds. So the idea is that so without model clouds, the point is that you need to adapt the way you develop for different platform, and then here you have just a single set of deployment scripts and code and so on. So you have the quality management done in a single way with these components. So we used this cost estimation for our case study, and we used it to do this the life cycle management. But I would say that it's like we deployed the application, we integrate it to our product. So we got in our product the view of how our nodes doing, what's the CPU utilization. So we integrate that into the application itself. Okay, so since it's open source summit, so just an idea of what we did in terms of dissemination. So we have the standard things like papers, books, and social networks presence. We did some webinars. It was very nice to 2 minutes. Okay, I just have one slide. It's good. So we were part of some standardization efforts, and we did some collaboration with other European projects based on this CloudML modeling language that was kind of shared between different projects, but with each one moving it to a different direction. So we publish all those open source repositories, and we reused lots of existing open source software to build. And what did you see? So yes, so these are the pointers to the websites of the project and to Creator for Clouds in Modeli, in Node4j. So, and then we published it since the end of the first year. We had already Creator for Clouds there, and we started. Comment?
Model clouds in Monaco. I don't believe that one.
Ah.
Why you have a time point? The second theory should be much more complex than that.
Let's see. So, any comments? Not on the second theory of Einstein's?
Yeah, so by the way, you can check on the website. So Model Clouds has got some assets on Apple already. So there's 10 different assets. So the only one we're missing is the full installation already repackaged. But that's something that we're going to work on together.
Yeah, I think we'll do. I mean, the remark on Elisabetta is about, because I've asked her to provide us with some executables for the app store for the factory. And she already agreed to do this, but I think she has no time.
She rushed for the review, and yes.
Right. So I hope I hear pretty fast from her.
I hope too.
Great.
Okay. Thank you.
Thank you.
Any questions? Go.
Are there any use case for software? applications on hybrid cloud, private and public clouds with different types?
Yes, that's part of the idea of the project of multi-clouds, because that's the motivation behind of our case study, because we have different kinds of customers, and we are selling this modeling as a service. That's the product we use as a case study. I didn't write it here, but that's the product. It's modeling as a service, and then we have some people that really don't want to have the models in a public cloud, and but we want to have a version of it that's available in the public cloud. So our motivation is, okay, how do we design it to make sure that we don't have to spend a lot of time to support both versions? So that's part of the initial motivation of the project, to say. Okay.